Good evening, everyone. If I could invite you to take your seats, please. We'll get the show on the road. So welcome to Fire, Carbon, and Climate. My name is Dorothy Gale, and I'm the past chair of the program committee. We respectfully acknowledge that Northumberland County, where we are based, is located on the traditional territory of the Mississauga, Anishinaabe, and Chippewa nations. We offer our gratitude to the First People for their care for and teaching about our earth and our relations. May we honor these teachings. So I had a few housekeeping matters, but I think everyone's been here before. Washrooms, we'll see about taking a break. It depends how restless you are after Juha finishes his talk. And I also going to take this for a personal reflection, which I'm not supposed to do. But this is the end of my time with NLC. I've been with the organization for 5 years, and I wanted to emphasize the Connect in Connect NLC. I've had the pleasure of having supper with Juha and Jeremy, who is speaking tomorrow, and I thought back to all the times I've been able to visit with the speakers and really connect with them. So what I'd like to do is to encourage you to talk to the speakers. If you're shy about asking questions, come up and talk to them after, because that's what we're really about. So, without further ado, let me get on here. Our speaker is Juha Metsaranta. He's a professional forester and a doctorate holder with the Canadian Forestry Service. He is part of the Carbon Accounting Team, which reports to the United Nations Intergovernmental Panel on Climate Change. Canada's forest carbon balance is significantly affected by climate change and forest fires. This past summer, our news was full of reports of extensive fires, particularly in Alberta and British Columbia. The impact of climate change is here now in 2023, not waiting to hit us carbon reduction targets in 2030 or 2050, depending on if you ask Ottawa or Edmonton. Juha has a Bachelor of Science in Forestry from Lakehead University and a PhD from the University of Alberta. And we did talk about his Alberta past when we were at supper. He is a scientist and a modeler, which means he's a bit of a nerd, but don't hold that against him, because I was a modeler too for animal diseases, and models are useful. I don't know if you're going to use that slide. They're all wrong, but they are useful. So he's of Finnish heritage, and he also knows a bit about European forest management, which differs a bit from our Canadian model. So without further ado, over to Juha, and give us some information about the carbon accounting in our Canadian forests.
Okay, well, thanks very much for that very thorough introduction. I didn't realize that. I don't think I sent you all of that, so you must have done some research about it. Okay. Overview. So I was going to talk about me a little bit. I still will. And then I'm going to talk about these 4 sort of small topics: Canada's forests, climate change in forests, carbon and wildfire. And I guess, like Dorothy said, the motivation for why I guess I'm here is because, we all experienced, this events this summer where it might have been the first time that, that you lived somewhere where, you had this wildfire smoke in the air. And so this is like a thing that, if you're in British Columbia or Alberta, this has been happening regularly. And we anticipate it's likely to be something that's becomes more and more normal with time. So about me, so this is my name. I'm Juha Metsaranta, and I'm a husband and a father of 3 children. So they make me care about the future. I guess I would call myself, I'm a Northern Ontario Finn. I don't know if any people know this, but like Thunder Bay has a lot of people of Finnish heritage, and that's kind of where I'm from. So, and I'm a Nordic skier, a cyclist, and a self-propelled outdoor explorer. So that's a picture of me in 1976 with my dad. And I don't know if he looks like me, but you can tell it's not modern because of the bell-bottom pants here, right? Yeah. So I put that in there because my dad recently passed away, so I've been thinking about him a lot. And kind of what I learned from him and stuff like that. So why forestry? Why did I choose this as something that I was going to study? So I went I went to high school from 1990 to 1995 without the internet. Okay, so that I might be in the last generation where that happened. Where I went to is Hillcrest High School in Thunder Bay, Ontario. It doesn't exist anymore. It's condos now. And so I just want to go over this a little bit. So my cultural touchstones, some of the things that I remember from growing up, it's grunge, the grunge music. If you remember Nirvana, I don't know. You might not. But there's also these things that were happening then, the Gulf War, there's the war in the Balkans, and there's this war in the woods. And you might know about that. It's in Clayoquot Sound and Temagami, the logging protests. So this is why I wanted to know more about that. And so that's why this is what I guess chose to do for my profession. So the only thing I'll correct Dorothy on this is that I'm not actually an RPF. I'm not a registered professional forester. So I've never had to do that for any of the jobs that I've had. I guess I could, but I don't. You're supposed to. I don't want to claim something that I'm not. But I did do a degree in forestry. So these are the things that I've worked on. So as Dorothy said, I'm a research scientist at the Canadian Forest Service. So in my position, we have these rankings, and from 1 to 5, I'm ranked at level 3. So I'd call myself, you can call me a mid-level government scientist. Is kind of how. So in terms of science, I've had some achievements. We have these big journals, the Proceedings of the National Academy of Science, and then there's the Nature and Science journals. I've been part of all kinds of articles published in those places, but I've never won any Olympic medals in skiing or the polka dot jersey at the Tour de France, so I don't know whether I've actually achieved anything, but anyway. So this is where I work, the Canadian Forest Service. So we're a federal government research organization and a part of Natural Resources Canada, and we have 6 research centers across Canada. There's in Victoria, Edmonton, Sault Ste. Marie, Quebec City, Fredericton, and Corner Brook. So I'm part of the Northern Forestry Center, which is in Edmonton, just on the org chart. So we work on a bunch of different research areas like forest climate change, wildfire and pest management, sustainable forest management, forest sector competitiveness, et cetera, et cetera. So what we kind of do, I guess, we don't really have any regulatory role or anything, but what we do is we do research and we provide scientific advice or analysis for policymakers. So the team that I'm part of, it's called the CF Canadian. This is pretty busy. We usually do this in about 4 slides, but I'm not going to talk about all this. So we're part of this research team, I guess, called the Canadian Forest Service Carbon Accounting. So we're a team of scientists, analysts, software engineers, and we do stuff like forest carbon science and climate change mitigation research. And then we also develop software like forest and harvested wood products, carbon models that we provide freely, and that we provide training for, things like this. So we build this software and support it and share it freely with people. So one of the things that we do, I guess one of the main reasons for why we exist and use our own tools is that we develop the sort of forest sector estimates in our greenhouse gas inventory. So when Canada is required to report on greenhouse gas emissions to the UNFCCC, and we're the ones who do those calculations, and we report on the sort of area of forest here in the darker green called the managed forest, and I'll get into that a little bit. So let's see, what did I say next? Okay, yeah, so these are our models. I'm not going to go over this. We have this, if some people who might know, care about forestry, but we developed this sort of carbon budget model of the Canadian forest sector. And we train people in its use. And then we're creating a next generation of that sort of software system. And then we also have this other thing we call the Abstract Network Simulation Engine. So a very nerdy name, I guess. So this is what we use to sort of like track the fate of wood when it's harvested and used. in Canada and around the world. So I guess next thing I want to do, so I'm a scientist. And so I already got the question of what is it that you kind of do in a day? And this is so this is what my kids think I kind of do here, right? But that's not really what I do. So this is always a hard question to answer. So I do these, I write stuff, I kind of analyze data, I answer people's questions, I mentor new scientists, but really so I guess that's not really science. So science is kind of, I just want to sort of go over this so that we know it's not really it's really what it is like this process for learning about the world. Okay, so it's a process of like determining things about the world that might or might not be true. And so we try to explain the natural world using sort of like theories or hypotheses. And what these have to do is they have to make predictions that we can test. So that's a key thing. If you have a question that's a scientific question, it has to make a prediction, and then you have to be able to go out and gather observations or make experiments to evaluate whether these predictions are true or not. So this is what we do. So the other thing about when we learn things, if we think we know something, it's the knowledge that we think we gain, it's always provisional. So we have to be willing to revise what we know at any time in the face of new knowledge or tests. Okay, and so then the other thing that it's critical is that scientific explanations can only be ever proven wrong. They can never be proven right. Okay, so that's a key thing that when we make these predictions, what we're trying to do is gather information to prove ourselves wrong. We're not trying to prove ourselves right. Okay. And so the other thing here I'll say is that this is a science, we think we're this objective people and we're like just gathering knowledge impassionately or whatever, but it's a social process done by what we would call I would call it like the scientific community. So we're humans, and we have our community has expectations and norms of behavior, but we violate those sometimes. We have egos, we can get defensive, and there's power struggles and all that kind of thing. That happens because we're humans. It's a human community, so that happens. So I just wanted to say that because this is so they're the day-to-day activities. Sure, they're kind of hard to explain, but what we're basically doing, this is what we're doing as scientists. This is the things what we're doing. So then another concept, remember I said that we provide advice to policymakers. Okay, and this is I don't really have, I struggle to think about this, but what we try to do, and sometimes it happens, sometimes it doesn't, is that we try to, encourage governments, I guess my employer in my case, to make evidence-based policy. So this is we try to make policies and rules that are based somehow in evidence. And are influenced by things that we actually know to be true. This happens sometimes, but not all the time. And so I was asked a couple of months ago by the management of my center to kind of come up with do a presentation on how my work is integrating science and policy. So I kind of made a huge long presentation to criticize the whole process. And then I got asked not to do it. But one of the things I did was I created this. There's this sort of hierarchy about the considerations that we have, and we're sort of here at the bottom. We're below politics, we're below the law, and we're below the economy as separate from the science of economics. But we try our best. And so one of the things that we have this newsletter that we get, and it has a section in it called the Forest Science Communicators Corner. So one of the things I always get advice about is how to communicate better my message. Okay, and then because apparently if we can't get our messages across, it's our fault. So it's a bit, and I've sort of pushed back sometimes with that, and I've said, well, why don't you have a forest policymakers listeners corner? They did do that once, but it's actually really hard to find like research on this, how to get people to listen better to advice. There's no research on that. They found one thing about active listening, and then they did listen. They had they linked some articles in the newsletter about how to listen. Anyway, so I just put this in here because this is where I work, so I know realistically I'm down here at the bottom and I do my best, to do this, and we do a fairly good job of this most of the time. But anyway, so yeah, okay. So the cat, this is my trend. I got to transition to something else here. Okay, so we'll get into it. All right, so what do I got here? So what is a forest? Let's try to answer that question. So we know, so this is we can say that a forest is like a complex, adaptive ecosystem dominated by trees. It's a habitat for animals, birds, insects, biodiversity. It's a source of food, clean water, and fuel, and timber, and other things that human societies want. But it also does these other things we call ecosystem services. So some of these things could be things like protection against erosion, air purification, climate regulation by taking up and storing carbon, which is what I'll talk about. And I'm sure you've had a lot of other speakers who might have spoken to this, where it's like a source of inspiration or a place of solace, an important part of human cultures. This is what we might think of the forest as. Okay. So then that's all good. And then, but this is, if we look into, we have this the FAO did this assessment, the Global Forest Resource Assessment, and it's a very boring definition of what a forest is. It's a land spanning 0.5 hectares, trees taller than 5 meters, and a canopy cover of more than 10% are capable of reaching this threshold in situ. So that's a very, when you reduce it down, this is the sort of boring definition. And so a tree, we have to define what that is. So in this particular thing, they've defined a tree as a woody perennial plant, typically having a single stem or trunk growing to a considerable height and bearing lateral branches at some distance from the ground. So that's a tree. So the point of this is to sort of make a joke about how, the forest we have all these definitions, but then we have to boil it down to okay, well, it's 0.5 hectares, 5 meters, this kind of thing. But the key thing here is that these two, remember that, I want to make the point that these are forests here, both of these, right? So when these baby trees, the seeds germinate, they're in this vulnerable stage. That's capable of reaching 5 meters in height. So we might not imagine that way, but that's a forest too. So the next one here is, so this is one where so there's some dispute about some of these things, about what exactly, so because there's people who care tremendously about certain aspects of these things, but so we might want to define certain kinds of forest, like a managed forest. So you might imagine that this is this managed forest, this industrial forest with these rows of trees, managed, sort of planted to maximize wood production or whatever. And that is a managed forest, but it's not, managed forests aren't exclusively like this. So then we might also have, we might care about old growth forests and old trees, and those are obviously important. And there's some definitions of that. And I listened to a podcast about old growth forests the other day. A person who's actually an expert in these things, and he suggested that he doesn't really want to actually define it, because no matter how you define it, somebody's going to be upset at you. So then the other thing that I want to define is this idea of a primary forest. So this is something that you might hear there. Maybe in the news, you might be interested in forests. You might read something about primary forests and how, we don't have enough of these things in Canada or whatever. But so this would be a definition of this is a naturally regenerated forests of native trees with no clearly evident signs of human activity and ecological processes that are not disrupted. So, this would be like areas that we might want to conserve because they're free of human disturbance or whatever. And then another sort of complex term related to forests is deforestation. Okay, you might hear that. and so the technical definition that we might use is in my world is when forest land is converted to a different land use. So you clear from the land, you eliminate the trees, and then you build, maybe you build agricultural fields or a golf course or whatever. So, but there has to be this change in land use. But what you often hear, deforestation is, if you clear the trees or you harvest the trees. But if the plan is that you're going to, replace the large trees with small ones, that's still a forest. So that's not necessarily deforestation. Then we have this other thing that we're trying to avoid is this idea of degrading, forest degradation. This is something that we're also concerned about. So this is when we do some sort of a management activity, we don't do it properly, and the forest has lost capacity to provide important goods and services to people. So these are some other sort of forests or forest-related terms that we might want to think about. So moving on here, okay, so this is where, we have that definition of forests with the 0.5 hectares or whatever you want to call it. So that this is a map of where we have this program where I work called the National Forest Inventory. And there's a website you can go to hereafter where they really create all kinds of nice maps of Canada's forests. So this is one, just to show where it is. So we have, we can see here the dominant genus, which, or I guess the type of tree species that's growing here in each different part of the country. And yeah, there's all kinds of maps. There's maps of disturbances, maps of biomass, and all kinds of things that we've developed, and you can go and have a look at, and people download and use those for analysis. So the other thing that my employer does is we create this report each year, the State of Canada's Forests. And so, we usually, what we do in here is we sort of report on different indicators about okay, how are we doing in terms of managing the forest sustainably, or it'll give you different statistics about okay, well, how much area of forest is in Canada, and you usually don't compare it to how many some small European country will fit into Canada or whatever. So, then it'll, that's what it'll do. So in this case, this year, I guess what we've chosen to focus on are the area of protective forest and how that's changed since 1990. And then, we'll usually provide some updates on things like how much area is affected by insect pests or that has been burned by wildfire or been harvested. And we'll also sort of sometimes make a certain point that we might want to make, for example, we might want to continually point out to people about this thing about how forests harvested on public land must be regenerated. So things like this. So you can get all kinds of information about Canada's forests, usually in this annual State of the Forest report. So we've been doing this since 1991, and one of the things, my dad was sort of like a local historian, so I like to go and look at the history of stuff. This is sort of a thing that I went and looked back at when thinking about what I might want to talk to you guys about today. And so one of the things that we actually did in 1991 already, and I was surprised when I saw this, is that we weren't really that concerned about climate change. I mean, scientists knew it was happening or whatever, but we were already reporting on how much carbon was in Canada's forest. So I guess we were a little bit forward thinking back then. And we also have these interesting things about, what were the things that we were thinking about back then in terms of threats to forests and how those might have changed. So back then what we were worried about was forest fires, just like we are today. We were also worried back then about acid rain, if you remember that. We had, that was something that we were really worried about. And we were also worried about, mismanagement of forests. And I guess we're probably still worried about that today. And then another thing that was interesting back then was, they did the survey of public perceptions of certain things, comparing the public versus foresters. And, we talk about today, we often hear this thing about there's polarization and society. And I think that there was polarization in certain things even back then. So definitely the public thought that old growth forests should be protected, that clear cutting is a poor forestry practice, and that the chemicals used in forest management are a threat to human health. the public very much, agreed with that, and they were sort of at odds with professional foresters at the time about all of those things. Some of this stuff I think has changed, and I'll show another survey later about that. Okay, all right, I'm done that part. Okay, what did I want to talk about next? Right, okay, climate change. Okay, so this is the climate change. Okay, so there's two things I'm going to talk about a little bit about, like the scientific base of this, because I think it's important. There's a few neat things in here. So there's two things that organizations that people might want to know about. So there's this UNFCCC, that's the United Nations Framework Convention on Climate Change, this treaty to which Canada is a signatory, which sort of commits us to certain things, and one of them is like, well, we have these aspirational goals about greenhouse gas emission reductions, and other things. But we also are, this is why this is who we report to in terms of these like national inventory reports. So the other thing you might have heard about is the IPCC, the Intergovernmental Panel on Climate Change. So this is the body that puts out the scientific reports about the state of climate change. I think there was a recent one, and I think that was the 6th assessment report. And then it also writes these guidelines for how we're supposed to report on greenhouse gases. So it says it's often very prescriptive. So you have to do these things, and you have to follow these rules, be in compliance with the, and we aim to be in. And sometimes when we do this sort of modeling, we're occasionally like audited, I guess, internationally through this. So climate change, right? Okay, so this is the. I didn't want to have things. So this is basically the greenhouse effect in a nutshell. Okay, so we have light comes into the Earth as shortwave radiation, is reflected as heat or long-wave radiation, and the greenhouse gases such as carbon dioxide sort of insulate the atmosphere and reflect more of this back than normally would have occurred. So this is actually something, this may be of interest to you, but there's this sort of very happy looking guy right here. His name is Svante Arrhenius. So he already worked out most of these predictions of what is supposed to happen in 1896. So I guess, as I understand it, there's a whole series of mathematical calculations you had to go through, but you kind of had to do it all by hand. So he's like optimizing these equations and writing it out, taking months and months to solve these equations. But what he basically what he basically found is that, his predictions were that increased carbon dioxide in the air will increase ground temperatures. There will be more effect near the poles than near the equator. The impact will be stronger in the northern hemisphere, etc. And basically, these are all true, right? So the basics of what's happening here were already worked out by this guy over a century ago. The other thing I just have on this slide is that we know that carbon dioxide is a greenhouse gas, but then there's these others like methane and nitrous oxide and others that are also do the same thing. And they're sort of standardized by this into equivalent units called carbon dioxide equivalents, based on this thing called the global warming potential, how much warming or insulation that they cause. So like it might be of interest to some. So methane is something that, it's sometimes of a concern, but this is like, for example, causes 30 times more warming than does CO2. Okay, yeah, so this is called the Keeling curve. So this is, this is the observations of carbon dioxide concentrations in the air at the Mauna Loa Observatory that were started by this guy named, I think it's Charles Keeling in the 1960s. So this is you can go to this website and it'll give you, like, you can download the most recent graph, and you can look at, okay, well, there's all these sort of proxies or from ice cores and things like this of what the CO2 concentration was for like thousands of years into the past. And you can look at that. There's a nice website. You can go to that. But these are the latest readings as of October 5th. So the one thing you notice on here is that there's this sort of annual variation. And that's kind of what that is. That's kind of the Earth breathing. So in a sense, that's what's happening there. That's basically like the annual cycle of where plants grow in the northern hemisphere and take up carbon, and then they die. And then so that's sort of what's causing that. So that's basically vegetation drawing it down partially each year. by growing. Okay, so this is another sort of this global carbon project. So this is a graph of like how this is the carbon where it, I guess this is probably in CO2 equivalent units. I can't remember if this includes all the other gases, but in any case, you can also go here and they will give you these charts and graphs and all kinds of data that you want to. So this is what we're emitting globally. And you can see there's a few, we did have this decline in emissions with the COVID pandemic of about 5%, but we're back basically to where we were before that. And then we have some other things like the global financial crisis, you remember from 2008, that caused a bit of a decline in emissions with reduction in economic activity. There's another one here earlier with the dissolution of the Soviet Union that caused a decline, but this is kind of the state where we're at now. This is how much, we're kind of putting up into the atmosphere. So these are you can also get this kind of information from there. So these are a little bit older numbers. I didn't have time to sort of update this for modern, but the percentages are the same. So about 90% of that is from the emissions are fossil fuel burning and cement, and then another like 10 to 12 is from deforestation and land use change that causes emissions. So what happens to that this amount that's emitted, only about half of it stays in the atmosphere, typically. So we have about half of it is taken up either by oceans or by basically terrestrial ecosystems, including forests. So that's this 30% here. So we have a question some that we can ask ourselves is, so we get this service where we emit about this amount, and only half of it stays in the atmosphere. Half of it is sort of taken up by oceans or forests or grasslands and other type vegetation. So the question we have is, this is a carbon sink in vegetation. Can this be sustained or enhanced? And so why this is an important question here is that, I have I'll just a small aside here. So I looked over this afternoon, like, oh, I have so many graphs in here. So I apologize. I'm a scientist. I got to do graphs. I'll try to explain them if you don't want to kind of just, I don't want to look at the graph. Okay, so this is a famous graph that a number of us show. This is probably like in my field, this is like everybody's got this graph in their presentation. So what this is, so in the climate models that make the predictions about, there's also a land model that's in there. And so this is and they can predict that, okay, over time, you can forecast over time how much, under certain conditions, how much carbon the land is going to uptake. So that's what this value is here. And then if you project it out to 2100, you can get vastly different numbers. Okay, so some models will predict that, that the land will be emitting 6 gigatons of carbon. Others, it'll sort of predict that it'll be, taking up an additional 12 or whatever. So what these are called are feedbacks. Okay, so there's one that's a negative feedback. So the sink in the forests gets stronger with climate change. So this could be something like, carbon dioxide concentration in the atmosphere increases, so plants grow faster. It could be something like that, right? So then there's another one where it's a positive feedback. In this case, positive is a bad thing and negative is a good thing, okay? So this is when as the climate warms, the sink decreases. So this could be like, if you imagine here in Ontario, we have this vast peatland in the Hudson Bay lowlands. So that there's a lot of carbon stored there, but if it gets warmer, then that could start decaying at a faster rate. So that would be an example of a positive feedback. So it gets worse rather than better. So what we care about here is that, this is like an impact. If in fact we have negative feedbacks and we want to stabilize emissions or whatever, then the ecosystems are helping us. If it's the other way around, it's harming us. We've got a bigger problem to solve. Okay, so that's the point of that. So as far as forests, so this is from a couple of years ago. This is we have also at our institute, we have these things called forest health surveys. So we'll fly around and we'll try to figure out where forests have problems. So this is stuff from about 10 years ago. So there's been, a degree of warming or whatever. And so these are things we've already seen that are in forests, in sort of Western Canada and the Northwest Territories that are ooh, and I should have like looked at it. So these are things like, there's trees dying. We have like permafrost is kind of collapsing in certain areas, and then we have like insect outbreaks that are occurring further north where they shouldn't have been. So these are things that are already happening in the forest with the warming that we have. So coming back to this, so 2023, this is another place you can go to. So to get this kind of information there's a website from I guess it's the Goddard Space Institute of NASA. They have like you can download graphs like the maps like this and graphs. So basically, what we've observed this year is that this is basically the warmest summer that on record in their modeling and then in their data. So there really isn't anywhere on Earth that was, well, a few places down here in Antarctica that were colder, but everywhere is warmer. And so we experienced that here in Canada this year for sure. So, okay, so here, this is a thing that I showed you that survey about the opinions of the public versus professional foresters in 1991. So occasionally we do this. So this is a survey that I just discovered last week. I know a couple of these people. So they surveyed about 1,200 people working in the forest sector. So that's writ large industry, consultants, academics, NGOs, etc. And so what they found in this survey was that, for the most part, people who work in the forestry or forest sector, they appreciate that this climate change is a real thing that's happening. It's having significant impacts on their industry already, and there's a need to change what they're doing now. But there's also this thing that we don't quite know what to do yet, or how it is to be done. Whatever the change there needs to be, we don't know how we're going to do that. That's kind of like, the result of that. And that really sort of corresponds with some of my own personal experience and some of my own work. So in this recently, in some of my own projects, I've had to talk to people in, the sort of, I guess, in the forest inventory parts of each provincial government. And it's pretty much acknowledged that, like, at least amongst the technical staff, and sometimes at higher levels, that this is like a real thing that they're going to have to deal with. So that's a little bit different. There's more of an agreement now, like at least that this is, at least within this sector, that this is a real thing that we're going to have to deal with. And I think that has largely to do with, because a lot of people have personal experiences that they've seen what the impacts of this have already been, like I mentioned. Okay, and we might have seen. So this is another thing. So that another reason why there might be this, unanimity that we have to do something about it is the wildfire season, I guess, that we've just experienced. So these are values of September 6th. So we get these, we have people in my organization who did, I think about every 2 weeks, we got the situation report. So the last one I had, and it was about September 6th. So all of these have gone up, these values, but it's roughly correct. Okay, so this 16.5 million hectares burned, I think, is about, it's more than that now. I don't know the exact numbers, but I think the second highest was somewhere, it was either 1989 or 1995. I right before I finished doing this, maybe I should look that up so I can say, but it was somewhere around 7 to 8 million. So this is twice as big as the last next highest or whatever. So this is just some other sort of like gives you some stats on evacuations, and we all heard this. We were watching the news in the summer, so this isn't news to anybody. But we might. This is kind of where the fires were or whatever. So another couple of different ways of looking at this. So the way that we, the things that we gather, the information that we gather about fires is we count how many there are and we count how much area is burned, okay? So this is the graph that I'm showing here. I'll try to explain. So this is like the cumulative area that's burned week by week during this year compared to about, the last 10 years. So you can see it's like off the charts higher. But the one thing that's sort of interesting is that, in terms of the numbers of fires, we're actually like not that far off like a typical average, right? So the way that I guess this is being interpreted is that like, that there's this, we all know that like we attempt to suppress fires, things like this. So this is possibly an indicator that like the conditions for wildfire are so severe that we can't suppress them anymore in a much higher percentage of cases than we used to be. So I was explaining over. So these values that we get. So these come from these sort of like rough maps, okay, that we can put together quickly during the year. And usually it takes a couple of years. We usually map them a little bit better, but you have to collect this sort of more detailed satellite imagery. So these values usually go down by a little bit once the correct mapping is done or whatever. So, but you have to keep that in mind that these are just done by these sort of satellite hotspots. It's called, they give a rough estimate of what the number is, but it'll go down by a few percent. It's not like a huge correction. But anyway, we do have a really good system in Canada for mapping wildfires. So just some additional stuff here. So, okay, so there's a number of provinces. It wasn't in terms of Ontario, we had a relatively bad, I think it was average bad, but not the worst ever. So, but there was records set in 5 different provinces: Quebec, Northwest Territories, Alberta, and BC, and then Nova Scotia. So you can see that. So one of the interesting things here we did see that we had those evacuations in Halifax and places burned, but that was still relatively a small amount of area. Nova Scotia doesn't really experience that a lot, so it's not. These are in the 25,000 versus 5.5 million, whatever. It's an order of magnitude different. Okay, so then I guess this is something that I debated putting in here, but I guess the idea is that could this have been predicted? Okay, so this is so we've known for a long time that with warming climate, the area burned by wildfire is going to go up. It's not well, we do use rocket science, but it's not really rocket science. If it gets drier and that we're going to have more burning. So I would say that this is a thing where in my area, I would say maybe. So we have this. So we have this bias in sort of in forestry and forest management to think of things returning to the forest disturbances returning to the forest periodically like clockwork. Okay, so because we want things to be the same, we want to justify that what we're doing, that when we harvest a forest, that we're not really affecting things negatively because it's doing what wildfire would have done anyway. So we have this. So the way that we describe this is in these things called the fire return interval, and the way what that usually is this number that describes, okay, if you have a point in the forest, and you can imagine we're in the boreal forest in Ontario, it would burn somewhere between let's say about every 100 years. So there will be a return interval. So it's you can imagine that it's this thing that's kind of we want to harvest the forest every 80 years. So we create a statistic about fire that kind of mimics that. And we sort of had this blind spot around predicting extreme rare events. And then this is something I'm going to show you about. This is my own sort of research, and I apologize. I got a wave graphs again, but what I've been trying to do here, what I've done lately is I've tried to introduce this concept of a return period. I don't know if any of you are engineers, but when we design in engineering, we often think of these 100-year events, like 100-year floods and things like this. So that we've never thought about wildfire in this way, but we have the mathematical models to be able to do that. And so when we do that, for example, this is in British Columbia, we have this amazing time series of area burned. Somebody's put together maps so we know how much area has burned since 1919 somehow. And so if we look at what I've done in this paper here is that I've plotted for British Columbia. This is the once every 100-year area burn and how that's changed over time. So if you look at this is a 1 million hectares across here. So if we were looking at it that way, we probably should have been able to predict that some of these things were going to happen if we were looking at it this way. But we haven't been. It's sort of been a blind spot. And this is something that I'm currently working on, trying to make people think about it, things this way a little bit more. Okay. So I got to go to the next one. The cat's confused now. Okay. So, all right. So the forest sector and its carbon cycle. So I'm going to talk about, so this is a little picture here. So this is, if you imagine, this is what we think, that we can draw the schematic of the forest sector. Okay. We have the forest over here. It's the trees are growing. It's taking up carbon. We also have dead trees and soil and things like that. Those are decaying, and that's releasing carbon. And these are large fluxes to and from the atmosphere. These are big numbers. Then we have fire over here that's releasing carbon. We might have this deforestation. Remember, land use change. We're changing forest to some other land use. We release carbon from that. Then we have afforestation. This is when we're planting some trees in areas that aren't forest. So this is an activity that we can undertake, and that's taking up carbon. And then we're also harvesting the forest, and there's some controversy around that. But when we harvest the forest, what happens is that there's some emissions. If we we often burn the piles that are left over, and that causes emissions. But most of what happens is that there's this lateral transfer to a harvested wood products sector. So we're using that wood for various things. We used to read newspapers. We don't do that much anymore. Yeah, but we build houses, and we have all kinds of things like that. And when we're finished with some product, we dispose it in landfills, and there's emissions from there. We may also burn some wood for bioenergy, and there's emissions. So these are all the things that we're trying to quantify when we think about the carbon cycle of the forest sector. So yeah, for some reason I put two different graphs saying exactly the same thing here. So yeah, so I could just say, so then we have carbon that's sequestered from growth, carbon that's lost through decay, which we call respiration, and that could happen from dead trees or soil. And then we have these disturbances that release carbon, and then we have lateral transfers of carbon when we harvested wood products. Okay, so what do I need? Okay, right. So this is a little bit of an aside. I want to talk about scales. So, because it's important for the next couple of things I'm going to talk about. So when we're in ecosystems, we often talk about the scale of what we're talking about. So what this refers to is this combination of time and space around which we organize sort of our understanding and our predictions about things. So we start from small things here. We might talk about things that are happening at the level of trees. So in units of square meters and in time of minutes to hours. And then we have this higher level of organization that we call a forest stand. So this would be like a collection of kind of a population of trees that kind of has a consistent age and a consistent combination of species. So these are usually in hectares, and we might try to understand those over years to decades. And then we have this landscape, which we would look at in units of square kilometers, and we might study that and make forecasts from decades to centuries. Okay, so that's a bit of an aside. So this is where this is a little bit of a little bit further detail about the carbon cycle in a forest. So the part where the plants are sequestering carbon from the atmosphere, the term we use for that in my science is called net primary production. So that's plants are doing photosynthesis, and it's converting biomass, or it's converting CO2 to biomass. Okay, so that's the part where there's a sink of carbon in the forest. So then there's this other thing called heterotrophic respiration. So that's what I referred to before as decay. So that's where like dead material in the soil and things like that are being released to the atmosphere. So those are the difference between those two is whether like a forest is taking up carbon or releasing it. It's the difference between net primary production, and you subtract from that this respiration, and that has this term called net ecosystem productivity. And when it's positive, the forest is a carbon sink. Okay, so that's kind of important to understand. And this is that, remember that the reason I went over those scales is because this is at the stand level. So that's this population of trees that's about consistent composition at the scale of like hectares. Okay, and so this is what it does. This is what net ecosystem production does over time with age at sort of the stand scale. So there's again a graph. Okay, so with this line here is at 0. Okay, and so when this net ecosystem production curve is below 0, it's a carbon source. And when it's above 0, it's a sink. So this is kind of the general pattern that happens. Okay, so when a forest is disturbed, we harvest it or it's burned for a period of time. You know, it could be sometimes several decades, but it could be only a few years. The forest is a source of carbon because the trees are not big enough. If you imagine there's these little tiny trees, they're not growing very much. Usually when there's a disturbance, there's all this dead stuff that gets added, and that stuff has to decay, so it's releasing carbon. So so this net ecosystem production is kind of like highest in these these young to mid-age stands. So if you imagine it's like there's this peak rate, and then this is when like you might hear the term sequestration. So this is when the sequestration, the rate at which it's taking up carbon is really high, but the amount of carbon in the forest is actually not that big. Like it's low. Like if you imagine a bucket, it's still half fill or whatever. And so when when the forest gets older, there's a decline. So sometime in this case, in this particular example, it's still positive, but sometimes this curve can reach all the way down to 0, where it becomes neutral again. But so this is in old stands. So the carbon sequestration, the amount by which it's changing each year, is lower, and it may even become 0 or negative in some cases. But the amount that is stored, in the amount of carbon in the forest in these old stands is really high. Okay, so whether at the next level, when you have a landscape, what's going to happen? It's going to depend on how much of your forest is in these 3 states. If you have a really young forest that's just been disturbed, obviously the whole thing is going to be a source, and it's not going to have very much carbon. In this middle stage, if all of your forest is kind of in this middle stage, it's going to be taking up a lot of carbon, but it's not going to be storing very much yet. And then when it's old, it's going to be storing a lot, but it might not be taking up a whole lot more. So that's why this is important. Okay. So next, if we move up to the next level, we also have this other term, the net biome productivity. So this is the production at an ecosystem level. This is like you have it's many thousands of square kilometers. So that's what we're describing here. So this is the net ecosystem production, that value in the last graph, minus the CO2 that's moved out of the ecosystem from disturbances. Okay, so disturbances will also cause some emissions. In the case of some of this will go to the atmosphere if it's combusted. So this is what wildfire does, or if we burn the slash piles after harvesting or whatever. And we also transfer some of this to harvested wood products. Okay, so this can have climate benefits too, which I'll get into. And it depends on a couple of things, like the service life of the wood that the products that you're producing. So if we're producing, long-lived wood products, so like that we use, this would be like lumber or panels, things like this. So that's in service for a long time. So just because it's harvested, it's not immediately emitted. And then products also have this thing called the substitution effect. So this is where, like, you have to imagine, there's this sort of counterfactual thing that you have to think about, is that if we weren't using wood to, say, build buildings, we would be doing something else, right? And so this might have so this would be, some of the things like steel and concrete, they have higher carbon emissions than wood would. wood, yeah. So then there's these, you have to consider these things. So this is not a huge area of my expertise, but I have a colleague, his name is Sheng Zi. He's very good. So he went to University of British Columbia and worked for this program called he works for the Forest Service now, but he was, I guess, training under this thing called the Pacific Climate Impacts Consortium or something like that. And so he has a nice website here and a YouTube video where he does a nice presentation on forest carbon benefits of harvested wood products. So there's a link here if anybody wants it. He does a much better job than I do of explaining that. So I guess taking down all that information, I guess I have to have some sort of a punchline here. So the question is, what is the managed forest carbon balance in Canada? Are we like a sink or a source of carbon? So in this NFC Mars system that we develop, we model, this green area, this sort of darker green area of forest here called the managed forest. That's what we are considering because, again, we're doing this for the purposes of the UNFCCC, which is concerned with anthropogenic greenhouse gas emissions, stuff that can be attributed to humans. So that's why we're sort of modeling only that. So the next thing we're going to show you, I guess, is at the landscape level, what this looks like for Canada. And so basically, this is another graph, and I apologize for that again, but this is basically, in this case, I guess the graph is reversed. So here's a zero line. So this is the greenhouse gas emissions or removals from Canada's forests. And if it's below the zero line, we're removing greenhouse gases. And if it's above the line, we're emitting them. So for that area of Canada, the sad story, I guess, is that the managed forests in Canada have been net emitters of greenhouse gases since 2002. And this is largely due often to this increase in wildfires, but also insect disturbances. So you can see that, okay, so we've had, what I've tried to show here in this figure is that there's this really strong relationship between the area that's disturbed by these natural disturbances and the fact that we're emitting carbon. So there's a second, I'm not going to get into this, but there's also this second partition of this land. So what we do now for our reporting is that this is for that total area of forest that I showed on the previous graph. We'd also partitioned that based on a series of negotiated rules into this categories of land that are primarily anthropogenically influenced, the parts that are influenced mostly by human activities. What happened there? Uh-oh. I have some more graphs. Okay, there we go. All right. So I'm not going to get into this, but so we have this other thing, and there's quite a lot of, we get a lot of grief over this partition that we've been doing, so what we've argued in Canada is that because most of this, it's so dominated by natural disturbances that we often can't control, that what we would like to do is to further subdivide this into partitions of land where we have influence and that we haven't influenced, and we've negotiated a set of rules around doing that. And so when we do this, and we get some grief over it because the anthropogenic partition is actually a sink. And the natural disturbance dominated category is where most of the sort of source is occurring. So we're doing some updates to some of the rules that that are around that. So I'm not going to get into showing that information too much right now because it's too much in flux still. But basically that's the reason for it, is that we're trying to separate out this to be able to demonstrate that when we take management action, that we're actually be able to move the needle on some of these numbers, and the natural disturbance effect is just so big compared to what we can do that if we would never be able to see it at this level. So the other thing I have up here, you'll notice this. So these are values you can get from the State of Canada's Forests Report website, and so so we're a few years behind there, 2020, and I've noted that with those, the number for 2023 will be off the scale somewhere up here. I think it's in the 800, but I don't. That's sort of very preliminary. Okay, yeah, the cat's still confused. All right, so the next thing I want to get into is like, can we actually do anything with forests to mitigate climate change? Okay, and so this is a paper that came out. It was in Science. You might have, if you're paying attention, you might have seen this. It got a bit of news press. So, global tree restoration potential. And you can go here. So these guys. So what these particular people argued was that you could solve climate change by just restoring forests everywhere in the world. And this is kind of what a lot of people who do this are like, this is too good to be true, sadly. And there's about 7 or 8. So when scientists disagree, we will write a commentary to the journal, and there's about 7 or 8 very critical commentaries for this one. We were actually considering doing one, but we looked and we're like, there's already a lot of, everybody's made the same point. So you can go in. They brought some attention to this tree planting, but it's not going to solve our problems, basically. So what I'm showing here. So this is in my team we've had a bit of turnover. So we had a fairly famous scientist who's just retired. His name is Werner Kurtz. He was sort of the senior scientist in our team. So he would show, when he was talking about what can forests do to help us solve the problem of climate change, this is what he would show. And the point that he would make is that forests and forestry can't solve the problem of fossil carbon emissions, but they can contribute. And that mostly remains to be true. And I'll show you some reasons why. And he would always show this sort of semi-apocalyptic photo from somewhere, I think in East Germany or maybe West Germany, where you've got the traffic jam we all want to avoid, and then the industrial emissions in the background. So let me just go through a few of these things. We do have planting programs, okay? You might have heard the federal government has this 2 billion trees planting program. And in Ontario, we have this Forests Ontario 50 million trees program. These are very valuable things to be undertaking. Okay, so the one thing that I'll just add about these is that when we're looking for places to plant trees, we have to remember earlier I had that slide about from the State of Forest report and I said, okay, well when we harvest forests, we legally have to already regenerate those forests, plant trees there. So these are trees that have to be planted in places where we don't have to do it. Because if we have to do it anyway, it's not going to be any benefit to just do something we had to do anyway. So that's an important thing so that's an important consideration. That's actually quite difficult to find places like that, where land which is not used, which is sort of not usable for agriculture, or that isn't already forest, or that isn't, somehow it's this empty land waiting for trees to be planted where we weren't already required to do so anyway. What's that?
I was just commenting on
Oh, okay.
the last line in that piece there.
Sure.
The
Yeah.
bottom line.
Yeah. So let me just go over this. So we did this. So with the Forests Ontario program, we sort of assessed the carbon benefit of that already. And so then what we found, so there's about 12,500 hectares assessed. We found about 80% of it is actually afforested, and we modeled it, and there will be a small benefit by 2060. So these are investments, but they're long-term investments in benefits. Yeah. So another thing, we like I mentioned, we have this polarization. So we have the same thing here. We have people who will we have all kinds of, we have different societal groups, okay, and they have different thoughts about how we should manage the forest to mitigate climate change. And if we wanted to sort of call it like a dichotomy, we would have like there's a stop harvesting or a use wood strategy. And so we draw this diagram right here that sort of, again, represents the forest sector, but we also add other sectors. So this is the forest, and here we have the ecosystem, and then we have the wood products. And then out here we have fossil fuel and other products. Okay, so if you imagine we followed a stop harvesting strategy to use the forest. So this box right here, this forest carbon in the forest ecosystem, that would get really big, right? But then we would also these arrows would become really small, and this arrow would become really big, right? Because we would still, we'd still build houses. We would still yeah. So this would be so. Then we have this other strategy where we can use wood. This box becomes a little smaller. These arrows become a little bigger, but ideally, then this arrow here becomes a little smaller. So we try to quantify as best we can some of these strategies, and we've done some work on trying to do that. So this is the other, I forgot to mention on the first slide, I have a colleague, Carolyn Smith, who, she does a lot of this work on mitigation strategies, okay, what we can do. So a few years ago, she did this, they worked on this mitigation analysis for British Columbia, where they looked at, they looked at these different strategies of that they called higher utilization, which is basically like if you're going to harvest a forest, you use all the wood with as much as possible. You try to waste as little as possible. And then we have this other strategy called the collecting harvest residues for bioenergy. So this is, again, so instead of, if we have this wood that isn't merchantable or isn't usable for anything, we collect that from the forest and we use that and generate electricity or energy or whatever. She also tested these strategies, which is to harvest less. So this would be sort of a conservation strategy where you decrease the harvested area, but then you increase the use of energy and material substitutes. And then we also have this other strategy, which is restricted harvest. So this is basically this is British Columbia, so we have much older forests. So they sort of said, okay, you cannot harvest anything over 250 years. And still maintain the harvest target. So they tried these things, and some of them, the bottom line of it is that all of these strategies work somewhere. Okay, and so it always depends on where you are. But where they looked at and this best strategy wherever you are, they called that a portfolio approach. But I guess if you look at it in total. The mitigation you get was sort of only 35% of what British Columbia was targeting to reduce by 2050. So it goes back to so you can do stuff in the forest, but you can't solve the problem. So another paper that we were part of. So this is I guess this is sort of the Nature Conservancy or Nature United. So they convened a large group of scientists, including us at the Canadian Forest Service, to look at natural climate solutions. So we call these actions that protect or better manage or restore nature to reduce greenhouse gas emissions. So we had a bunch of them in agriculture, wetlands, grasslands, and forests. So the end result of this was that we could probably offset about 11% of Canada's emissions in 2030. So again, it's you could take these actions, but it'll give you a bit of a benefit, but not that much. You still have to reduce emissions, basically. So now one of the things that, again, we found with the tree planting, like somebody noticed, the tree planting didn't give us a lot in 2030, but then it increases with time. So it's like part of this portfolio of solutions. They're short-term and long-term ones. So, if you have tree planting, you're not going to get a lot. We don't grow trees very quickly here in Canada. So you're not going to have a lot of benefit in 10 years. But in 30, 40, 50 years, you might. And there's a website down here where there's a really nice, they have a bunch of additional infographics and stuff like that you can go and look at. It's a really thorough study. Okay. So this is a thing that I worked on. So we looked at, so again, this is in British Columbia. So we looked at, okay, well, what if we took some of the areas that were really severely burned and we rehabilitated them? And what could we get from that? And what we basically found, I'm not going to go over these graphs, but we suggested that if we cared about mitigating climate change, it might be better for us to reduce wildfire risk and stop the emissions in the first place rather than doing something about it afterwards. Because so if you look at these numbers, these are the fire emissions. If you look at they're in the same units here. So, typically the range of values here, we have about, cumulatively you get about 2,000 megatons CO2e, and at best we could mitigate about 40. So it's a small fraction. Okay, so another thing I just want to go over here. So you might hear stuff about forestry offset projects. So this is where organizations or private, some sort of, industries or whatever, they will implement projects in the forest to get carbon credits that you can sell either in regulatory or voluntary markets. So I'm not going to go over this too much, but so one of the things that I just want to go over there is that there's these things that we have to consider before these things are real. Okay, so there's a bunch of when we call those factors additionality, leakage, and permanence. Okay, and this is key. They're all kind of key for any sort of forestry mitigation activity, but. So what additionality means is that if you do an activity that's going to sequester more carbon or emit less, then you have to compare that to some sort of a business as usual. Okay, so you have to so this is where you have to imagine like a counterfactual scenario that what would have happened if I didn't do the project. Okay, and there's a lot. So this is like. There's a lot of debate about how to calculate that business as usual baseline, because obviously it never happens. So different people might disagree about agree or disagree about what that might be. And then this other thing, it's called leakage. And so this is what basically happens. So if you imagine like a forestry conservation project where you say, okay, I have this area, I'm going to protect it from harvesting. Well, what may happen is that all the wood that was going to get harvested from there, it just happens somewhere else, right? And so then if you just shift this, it's called activity shifting leakage. So if you protect a forest, you somehow have to demonstrate that it's not just going to be harvested someplace else. And then there's this other issue, permanence. So often the removals that you get credited for have to be maintained for long periods of time, often 100+ years. And so there's obviously, if we've been listening, there's a risk, that there's a lot of these things could be reversed, either involuntarily because it burns, or in some cases voluntarily if landowners change, or then they might have different goals or whatever. So these are some of the things that there's different rules being negotiated around all of these things, and people who are involved are trying their best to make sure that when these credits are issued, that they represent something real, and these are some of the considerations in that. Okay. All right, so you can tell this is my signal to move on to a different topic right here. Okay. All right. So this is something, okay, so I'm kind of finished with the carbon part about this. But I did want to talk a little bit about science again, and what I talked about at the very beginning. So about how science is used in forest management. And so the way that I think of that is that we have this idea of adaptive management, which is this learning by doing process. So this is what we often have a lot of uncertainty about what a particular management action is going to do. So we try to set up experiments where we can learn, and this kind of works. Except sometimes what does happen is people are sometimes risk averse and they don't want to actually admit when some of their strategies have failed. And I guess the other thing is that we often, so another thing that's unique about, I guess, the forest management business is that the planning occurs over long time scales. Okay, so when we prepare plans, we will make forecasts for tens to decades to centuries into the future. So some of this is so this adaptive management is trying to reduce uncertainty about this, but one of the things that climate change is doing is that it's making some of this uncertainty irreducible. We just don't know in many cases what's going to happen. So one of the things I'll say one more thing about this one. One of the things that is that, so it often, what we have been doing in many cases is that we've sort of, we've become very efficient, but as a result, we've traded off sort of resilience. So there's this idea that if you can do things very efficiently, but then when there's a perturbation or something that affects the system, it's no longer resilient. It just self-destructs, right? So you need to have some sort of resilience, and often that reduces the apparent efficiency at any one point in time, right? So that's a problem, and that building resilience is something that we need to do. Okay, so the limits of science. Okay, so this is where, so I mentioned I do science. So one of the things I'm not supposed to do, even though I'm a human, is not to make moral judgments or aesthetic judgments, and we don't really, what science doesn't tell you to do is how to use scientific knowledge. So this is like a picture of a waste pile in a clear cut. And I guess we could ask, is this forest destruction, or was this a sustainable method for regenerating even-age stands of shade-intolerant tree species? Okay, so I guess those are value judgments. Building off that, what I wanted to get into here is sort of these are sort of two popular books. I don't know if anybody's read either of these things. Yeah. Okay. What these kind of describe is the kind of society I might want to live in, one where it's fair and kind, cooperative, nurturing, that kind of thing. And so what these sort of suggest is that forests are like this. Okay, so they're embodying our best values. And I guess I just wanted, so this is something that I really hate to show you, the next slide, okay? Because there's actually been a couple of recent papers that large groups of researchers that have kind of called into question some of the evidence behind some of those things. It's very sad. The woman who wrote this, Justine Cutts, she went to the same university, same department than I did. She works there. I kind of know her a little bit. There's a podcast called Your Forest. It's called Your Forests, and she was one of the guests on it. And doing this was actually very, very difficult and of a process to go through this and realize that the things that you were studying may or may not be true. So that's not, so that I feel like I'm a wet blanket on that. But when I read sort of that book, the Finding the Mother Tree, so the woman who wrote it, Suzanne Simard, so she was a British Columbia Forest Service scientist. That was the start of her career. And in her book, she has these descriptions of these forest vegetation management conference meetings. I don't know if you remember this, if you've read the book. And it's like she creates this drama, this dramatic, this sort of out of this very mundane thing that's part of my job every day, right? So I thought that was very, so I just, so there's and she describes it, one of the situations really eloquently. It's exactly how these things kind of work, where it's she's at the front, there's the conference and she's presenting, and then there's the government guys over here, right? And then there's the people, the industry people, they're kind of sitting over here, and then the scientists at the back, because they want to seem independent from everybody else, kind of. And so, in any case, so I actually went and looked up one of the events that's described in the book. It's this, she's presenting about this particular topic right here, this protocol for operational brushing evaluations, and that's why the reason why this story is important. What I read out of that story is not really this trees are connected and nurturing to each other, but it's a vegetation management story, because that's where she started out. That's where all of her research was in this thing that I know a little bit about, where remember when I said that at the beginning, it's we have this rule that harvested forests must be regenerated, but how do we know? Okay, and so how we know is we have these free to grow standards. So which is basically we're supposed to evaluate forests to determine if they have these sufficient numbers of crop tree conifers growing without competition. So these are often hardwood trees like birch, aspen, or alder. And so what she actually studied and came up with these ideas was the experiments where looking at these like forest competition studies where the discovery, where her like important vegetation management discovery was that removing the competition didn't actually do anything for the trees he wanted. And that the total growth of like the control sites, you know, where like, you know, you haven't removed, where there's the crop conifers and the competing vegetation, is often a lot higher when you don't remove it. And so this is something that's what I get out of that anyway. Whether it's the part about like the trees cooperating or whatever ends up being true or whatever. I just thought it was interesting because she's like so the stories in there about these conferences that like they're like exactly, you know, like my experience, my professional experience, and it's just so interesting that it's this sort of like great drama that's created out of it. Okay, so what else did I want to say? So one of the things, right? So related to that, so this idea here that was apparently controversial is that the you know, if you control the vegetation, you know, like it doesn't do anything. So we're actually, you know, that's one of the things that I'm working on in this to examine this experiment down here, a vegetation management experiment, and so this is sort of the carbon stocks. If you you apply different amounts of herbicide or whatever, and if you don't apply any herbicide, you know, that's actually the best thing you can do for in terms of carbon stocks. So this is like one of these mitigation activities that isn't really on our radar, but I'm starting to try to get on our radar. Okay. So the cat's got a sweater. I guess I must be getting close to the end. Okay, I do. So this is I'm struggling with this. I struggle with what I. Oh, gotta move on. My conclusions are here are very short. I haven't painted a very good picture, I don't think. I have to admit I am not hopeful, but I'm kind of a pessimist by nature at the same time. So one of the things, so as I mentioned at the beginning, you know, I'm this pessimism, you know, is in my DNA. I'm Finnish, so even though if you probably looked in the news, somehow Finland is the world's happiest country, all my cousins are like, how is this even possible? How bad is everywhere else? So one of the things is, so what a classic thing of my pessimism is that, you know, the story is like, you know, the Finnish businessman, he said, the best year ever, most profitable. So his reaction is, well, there's nowhere to go from here but down. But I guess maybe there's nowhere to go from here but up for some of these things. So if we take action, you know, like we could do things, I think. At least I hope. I'm not that pessimistic. So I mentioned this podcast right here, Your Forest Podcast. If any of you listen to podcasts, there's really good guests on there that talk about all these things. And a lot of times it's much more eloquently than I ever could. So I encourage you, if you're interested in forestry issues, it's very good.
I'd like to draw it to a close and thank Juha for his presentation. Very comprehensive. And we have time for a few questions. And Nedra's here with the microphone. There's another question here.
Thank you. Very interesting. About midway through your talk, you mentioned return periods for fire and that you are looking at these. And a question first before I ask the rest of my question.
Sure.
So that's return periods for fires within Canada?
Yeah, that's right. So I guess so, yeah, yes.
So my question is, are you looking at, or have you looked at, or do you think there's any merit in looking at whether these return periods are linked to worldwide events, whether they're geologic events, solar events, human activity events, and is that part of your plan?
Well, so probably I would say probably not. At the moment, it's not part of like I guess you could. I haven't thought about that. So I guess it's not really something that I would like. I guess you could use the same mathematical approaches if you wanted to, but I don't really. I think I would have enough work convincing people in sort of forest management and fire management to change the way they think about these things, without worrying about other areas. Would be my answer, if that makes sense.
I love your graphs, all of them. You had a graph about insect damage. Is
Yeah.
there anything that can be done about that? Because it looked like it had a huge effect.
Yeah, so that's right. So yes, you can. You can. Again, it depends. So for example, so there's the damaging insects are kind of defoliators, and then there's bark beetles. Okay, with defoliators, we used to apply these fairly noxious chemicals. I don't even remember, but now we can control them with BT, which is like I guess a bacteria, if I understand it. It sort of targets forget the insect. I think it's Lepidopteran caterpillars. But Bacillus thuringiensis. Yeah. So this is what the control measure that you can apply now that it's less controversial. And if you're organic farming, you can use BT to control things, and it's approved for that. Although, where I live, it's used for insect control, for mosquito control, sorry. And some people approve of it and others don't. But yeah, so in terms of like spruce budworm, there is like this is an insect, if you're in the 70s and 80s, was a major problem in Canada, and it sort of goes through these cycles, and it was in a low cycle, but it is increasing now again, especially in Eastern Canada. And so there is this idea. I think there are sort of BT programs that you can use for that. Bark beetles you can't do a lot about, I guess, because again you can't reach them with any like product because they're under the bark, they're protected. So what Alberta was trying to do in the early part of mountain pine beetle, which I didn't get into, was you would look around, you would basically like try to cut and burn. So you would kind of go along and you'd find the trees would turn red. And you would look for these things, then you would just cut them and burn it and hope that did anything. I don't think it. I think the conclusion is that it might have done a small amount of a positive effect, but mostly it's not. It's stopped by weather conditions rather than what we might be doing. Yeah. Yeah.
I was wondering if when you harvest trees and they wind up as studs in our house.
Yeah.
But that might be one of the happiest places for the wood because it doesn't rot and
That's
emit
right.
CO2s, or
Yeah.
the insects don't get it.
Yeah, that's right.
And all that sort of.
Yeah. Yeah, that's right. So I mean that's one of the in the strategies where you sort of like conserve forests while we're still going to want to build housing, right? So there's definitely like so there's again there is if that wasn't available to you to use that, you would have to use something else, and a lot of those would have a much higher environmental impact. And so that's I'm not advocating for one strategy versus another, but it's a consideration, and we do have models for that, and we know that like when you do for construction lumber, it does in our calculations it has a longer service life before it's disposed, so it would remain I guess sequestered in the human system for quite a long time.
Are there any other questions?
Thanks. I wondered whether it makes any difference what species of trees you plant when you manage to find areas to plant them, and how much diversity you need in a forest to make any difference in their carbon sequestering or emitting.
Yeah, so that's part of what like so that's silviculture. Part of that is the forest management planning is you obviously certain tree species are more suited to certain sites. So in our 2 billion trees program, one of the things the way we described it is you have to have the right tree in the right place, right? So determining what trees to plant where depends on like soil conditions, like the local climatic conditions, and this is like we're not, if it's properly managed, that's part of the decision that a forester would make when they're sort of assessing a site as to what species would be planted where. And so the diversity question, that's an interesting one. So obviously you may sometimes have a situation where you're stuck planting one or two species, because that's what you have available to you. But like obviously there are situations where like where like a higher diversity of tree species planted on a site, if you can do it, will you know, build that resilience. You know, because if there's a, you know, say there's an insect that or a disease that affects one versus the other, you know, you will have some that are, you know, still have some survivors, or there's often like these synergistic effects that we don't always understand, where like if you have diversity, you know, for example, like, you know, like a nitrogen fixing species. So some species like alder and some other things, you know, they'll fix nitrogen, they'll actually increase the fertility of the site. So there's those considerations. So I mean, it always so much depends, right? Sometimes it's suitable for a diversity of species. Sometimes you really should only plant one or maybe two. Depends. Yeah.
Thank you. Is there a question here?
Yeah, thank you. Have to do anything to this? No, it works. Your illustrations kind of brought something home to me that I've been struggling with trying to picture, which is when you look at the cycle, life cycle of a forest, whatever that is, it's really kind of a net zero, isn't it? I mean, it can soak up the carbon that it produces, but can it soak up more than it produces? Or is our problem really that we're going to the carbon sink of 50 million years ago and taking out several 100,000 years worth of carbon and burning it all in 1 year here, sort of thing?
Okay, so remember there's also the soil. Okay, so if you imagine that, like, so we can kind of do this in some of our modeling, where if you imagine, like, if you have a small amount of carbon in the soil, so the decay of that when it's modeled is essentially a percent, right? That's applied to, like, you know, a number. So if you have a small amount of carbon, it's only going to, within the soil, you're only releasing a little bit through decay. And then as a forest sort of, the forest is turning over material all the time. So, you know, foliage is falling every fall, you know, branches are turning over, trees are dying. So you do get a buildup of soil carbon eventually. So if you imagine a forest that goes through several cycles of burning and then regrowing, you know, you can, and depending on where you start, you can build up carbon in the soil over the long term if you're not removing too much. Yeah. So yeah.
I think I'd like to pull the evening to a close. It's 9 o'clock, and I would invite others, as I said in my preamble, if you want to talk in more detail with Juha, please wait and come up and talk to him later. So thank you. You're passionate and enthusiastic about all your work, and you've also described the limitations of what we can expect from our forests. I did raise this question, and I'll ask you about it later, the 2 million trees that the Liberals were looking at, and it's certainly not a panacea. We've had evidence of that. And I think the way we account for carbon in our forests is really important, and how it contributes to our report to the Intergovernmental Panel on Climate Change. I'd like to encourage everyone who hasn't signed up already for tomorrow to come tomorrow morning, because a lot of the questions tonight have been on forest management, and that is what Jeremy Williams is going to focus on. Jeremy is going to give a 20-minute short presentation on different forest managements and how it impacts, like the diversity of the forest versus monocultures, the burning scrub piles of the wood that they don't use, like you saw in the photo. And he's a professional forester. I didn't know you hadn't applied for your professional forester, like a professional engineer, but you still have a degree in forestry, so I think that's pretty good. Jeremy Williams is a professional forester, and he is now doing a consultancy. He has a PhD, and he has worked extensively on recommending forest management to the various lumber companies in Canada. And he'll describe the forces pressuring forest management today, and how perhaps by management we could better address the current challenges. Although you've heard the doom and gloom here, maybe we'll get a little bit of positive tomorrow. So now there's an important announcement from Barb Woolley.
Thank Thank you, Dorothy. I don't want to start with more doom and gloom, but next week, unfortunately, we've had to reschedule our talks. So we did have an in-person event scheduled for next Thursday evening, and unfortunately, our speakers had to be called away. He lives in Portugal, and so he's not going to be here. He has agreed to do a Zoom call or a Zoom webinar with us, hopefully November 16th, and it may even be an afternoon, but we will let you know. Anyone who's bought tickets, we've updated our website, etc. And hopefully you understand. It's really beyond the programming committee, so to be able to manage that. And also, it just seems to be a bad week, but the Friday morning event that was Zoom, it's about who has access to trees in urban forestry. That presentation will also be rescheduled for a week later, so it will be November the 10th at 10 a.m. However, November 9th, tree is a symbol, all good so far. And then we also have David Newland's concert on November 12th, so we hope you'll still attend. And thank you again to all our connectors. I also want to thank Dorothy. This was one of her last events as a program chair and program committee member. Just thanks again from everyone at NLC for your leadership and help in shaping this series and many others. Anyway, safe home, everyone. Thank you.